All right, so we're going to start talking about the last relationship that we're going to look at for the class. So up until this point, we've looked at lots of other ways of looking at variables. We looked at one categorical variable when we just looked at one proportion, or p. We looked at the relationship between two categorical variables when we did that chi-squared test for independence to see if the response variable was affected by the explanatory variable. We then shifted to quantitative data and investigated just looking at one quantitative variable when we investigated one mean, or mu. Then we looked at having both one categorical variable and one quantitative variable when we talked about independent versus paired means, as well as analysis of variance. The last thing we need to cover is what happens when we have two quantitative variables. So that's what we're going to investigate in this module, is looking at the relationship between two quantitative variables. We're going to be doing that by what's called simple linear regression. So let's go back and remember first just what a response variable and an explanatory variable are. So the response variable is generally the outcome of interest, the one that we really care about. Whereas the explanatory variable is thought to partially explain this response variable. Now, since these two variables that we are working with are now quantitative, we're going to be looking at them in different ways than we did when we had two categorical variables. In fact, inside this module, you may feel a little bit like you're back in algebra class when you're looking at y and x. So we're going to see if there's a relationship between x and y. And in order to know how to graph things and how to explain things, we need to figure out which one of these is the y variable and which one is the x variable. So the outcome of interest, this response variable, is going to be our y, and the explanatory variable that has that x in it is going to be the x variable. So we're going to see how x impacts y. So let's first talk about this through just a couple of examples to see where we might have these two quantitative variables. So you want to see what happens to a student's overall percentage in the class as they miss more classes when we were doing like a face-to-face class. So my two variables that I'm looking at here are the overall percentage in the class and kind of how many classes they miss. So those are my two variables. So we have our class percentage, which is quantitative, and then we also have our number of classes missed. And one of the first things we need to know is which one of these is x and which one of these is y. So which one is the one I really want to know, the outcome of interest, the response variable? Well, I want to see what happens to a student's overall percentage. That's what I really want to know. So that's going to be our y. And then we think the number of classes missed may impact that in some way. So we're going to think that it may explain their class percentage. Another example. Suppose we want to see if a house has more square footage, how that would actually influence the price of the house. So our two variables are the square footage and the price. So our square footage is one, price is the other. Again, hopefully you can see those are both quantitative in nature. So which one is really the one I care about, the outcome of interest, the response variable? Well, I want to see how price is influenced. Price is what I really want to know. And then we think square footage might explain the price of the house. Now, as as we start investigating this relationship between our two variables, we're going to do it in a few different ways that we're going to get into a little more specifically in future videos. Here we'll just briefly talk about them. The first thing that we're going to talk about is what's called a scatter plot. And the goal of a scatter plot is just a graph that we're going to create for two quantitative variables. So it's for our two quantitative variables. And this allows us to see if there's a relationship between x and y. Since it is a new graph that we haven't talked about, we will go into more detail on that in the next video. Then we're going to do what's called regression. And the goal of regression is to predict a value of y for a given x. So for example, I might say, well, if this house has 1,500 square feet, what would I predict the price of that house to be? That's the goal of regression, is to predict. And then finally, we'll talk about correlation toward the end of the module. The goal of that is to look at the strength of the relationship as well as the direction. But more specifically of just a relationship, it's for a linear relationship. And that's one of those words that we tend to use and assume we all know what that means, so let's just make sure we're all good. So when I say linear, I'm talking a straight line relationship. For example, we could look at a picture or scatter plot that we talk about in the next video, and there could be a pattern, but if it's not a straight line pattern, then correlation is not going to be something we would want to look at for that type of relationship. Alright, so in the next video, we'll start looking at discussing how or what we should really be looking for in a scatter plot.